So here we go. We start with the first lecture on wireless communication, introduction and historical background of wireless systems. The agenda of this lecture is going to be discussing the history of wireless systems in general, the starting point, the current available systems, and where are we going. And then we will discuss the technical challenges of wireless systems. Then we move to discuss about the next generation wireless systems, including 5G, 6G, and the ones beyond that. Spectrum regulation and standards. What are the available standards? What are the regulation? Who's responsible for regulating things? Emerging wireless systems, and some interesting applications about wireless communication. So, wireless history. Actually, wireless is very old. One of the oldest methods used for wireless communication is using for communication in general, not maybe it doesn't fit under wireless, using smoke signals. You might have watched some of the movies that Indians, they are using smokes to guide people, we are here, and there are different types of smoke for different type of accidents or different types of information you want to send to your, and that also flags. They use the flags, for example, red, blue, green, this, white. They understand that this means something when they raise the flag. From long distance, you can understand from the symbol, from that. This means that you use something from that thing, you understand some information and you interpret it the way you like. Even they use pigeons carrying messages and this and that. So we had this communication, the society in need of communication since the oldest ancient times. So as time goes, new inventions are required, new innovative things, because the one who invent first, the one who brings the technology first, ensures that he's going to be pioneer and leading the world in the future. That's why countries are competing, fighting with each other in technology. It's not now the physical power that determines who will be the strongest one in the world. It's the intelligence, it's the innovation, it's what your mind is capable of creating and doing. It's not like, it's now like one of the key things, for example, one of the key reasons for many countries to collapse and go deep down inside because of not adopting the new technologies. I'll give you an example. At the time of Ottoman Empire, for example, at that time in around 1901, everybody in Germany and Europe was using the printer. Now the printer, the copy machine, they were able to print and copy hundreds, thousands of books and manuscripts quickly. While when they came to Istanbul to adopt this technology, they saw that thousands of people will lose their jobs. So they had some empathy and they didn't want to create this mess and this problem. Well, who will employ these and what would these workers do after that? They were afraid of this. Europe was progressing in knowledge and printing and distributing and Istanbul is still adopting the old ancient methods in printing and documenting things. A time came where the country destroyed, cannot cope up with the new technologies, cannot produce much information as the others are producing. Why? Because we were afraid of adopting a new technology, because some people will lose their jobs. If you care about them, you must teach them how to use this new technology and employ them and make them really adopt it and feel they are secure while they are using it. Of course, now we don't want the current job you are doing, but we will train you and teach you to do something else. The same with wireless. The ones who won World War I and II are the ones who were using wireless some countries they were having wireless communication and some didn't hear even of it. You know, the messages that they were using, sending wirelessly, telegraph, Morse telegraph, and sending this German and USA and the first. And some countries, they didn't even know about this technology. Of course, the one who can send the information within minutes is not like the one who sent a soldier on a car to send the information and takes weeks or months. So it's really very profound concept that you must always be seeking for producing and learning new technologies and adopt them in your life. And this requires you to be a lifelong learner, not stopping. The ones who say, enough, this is I took master, PhD, I completed the science, I cannot do anything more. I got all the degrees. Education has nothing to do with the degrees you have. These are like licenses that shows that you are capable of doing something. But if you want to maintain your status and your influence, and your country should be with the people who are really eager and hungry for more knowledge, for more education. Why? Because it's not about education and how much information you get. Because if you don't know this, if you don't use this, you will be lacking behind. You will be left behind. People will exceed you. Companies are very afraid of this. On the level of companies, on the level of countries even more. So you must be, this is the single most important information that you need to really adopt in your life, that my education will be lifelong education. Never ends. Lasting forever. To keep improving, to keep growing, to keep benefiting. If you ever stop at a point, you are no longer a human being living, because living means growing, improving, impacting, contributing. Each day should add something new to your life, so that you can make sure that you are not left behind. So in 1880s, the first radio was invented by Marconi. After that, many sophisticated military radio systems were developed during and after World War II. And everybody knows, okay, these systems were available in World War II, but we were able to use phones and wireless in 1990s and 2000 almost. Why didn't we know about this? Usually the military, they exceed us, the commercial people, the civil, by 20 years. So I think when the military uses a technology for 20 years, after using it for 20 years, they give it for the public. So now we are using a technology that we think it's new, but it has been in the hands of the military for 20 years. Now we are here. They have technology that we don't know about it. We need 20 more years to know about that technology. So this means that there are new things, there are new technologies, new stuff going on, but we don't know about it. So military is usually the most advanced part of your country in terms of technology, must be, because those are the ones who are responsible for protecting your country and adopting any new technology that can help make your country stronger. So since then, we have witnessed exponential growth in cellular, since specifically after 1988. We started using voice communication, data, multimedia, and even in the third world countries, everybody has a smartphone right now, whether from Apple or Google or Samsung or even Huawei. And recently you have seen the conflict between Huawei and Google, and these companies fighting each one for making sure that his products can dominate the market. So in this picture, usually, if you can, I think you may not be able to see the text very clearly, but the point is, you on the x-axis you have the years from 1990 till today, and on the y-axis you have the number of subscribers, wireless communication subscribers. As you can see, it's growing rapidly. Each
representing
subscribers. Blue representing the past years, the current years, and these are estimated for the next coming ones. So it's growing, as you can see. And this shows that this field is really, there is more demand on it. If there is demand on it, means it requires more qualified engineers to understand and work and adopt and produce new technologies that can be used. So Wi-Fi also, besides the 4G, 5G, and the 3G and the GSM, you have Wi-Fi, which is a technology that helps everybody, because the current cellular system really cannot suffice the needs of the people in terms of data rate. Yes. For example, imagine hundreds, even thousands of megabytes every day from any home can be consumed. And a wireless network, like from towers directly from Turkcell or Turk cannot cope up with this demand. To mitigate this problem, they use Wi-Fi. Wi-Fi is something indoor, can be backboned by your wireline communication company like Turk Telecom, so that you can serve the huge demand that you have. But the future is aiming actually to be able to use like hundreds, thousands of megabytes, gigabit per second data rate, wirelessly, directly from any place, not from inside your home only. So that's the goal in the future, even if you are moving with the speed of the train. That's really very challenging. Wi-Fi, the problem with Wi-Fi, you can only use it inside, indoor almost, or 100 meters away from your indoor. And the further you go, the signal degrades a little bit and you cannot make use of it. Plus Wi-Fi, you have Bluetooth, you have satellite communication, you have Zigbee, you have RFIC, and many more technologies. In future wireless networks, it's not going to be only ground terrestrial network. It's going to be air network, where you have these drones, you know them? These drones can be, in the future, they expect that you will have a ground smartphone and a flying smartphone for your endpoint, like you want to send your phone for an area to capture, record, move, take photos, do this, do that. So you have a drone that can act like your flying smartphone. I don't know what type of application you might need that for, but obviously they are currently in the standard in the 3GPP, they are designing the communication network in such a way that they can serve these flying phones, these flying smartphones on the air. Plus, you will have not only centralized networks, but also decentralized, distributed, ad hoc to ad hoc. The devices can communicate directly with each other. You don't need to go to the base station and come back and talk, because this causes delay and consumes too much power, which is easier to reach a home, to reach a phone which is 10 meters away from you, or a base station 1 kilometer away from you. Of course, a phone closer to you, because it requires less power and doesn't take too much time for your signal to reach forth and back. So it saves power and latency. And the surprising and the new thing about future wireless communication system is the fact that you are not going to use only your smartphone. With the emergence of Internet of Things, and where you can connect any physical subject to the internet, any physical object to the internet, in that case you will have thousands of devices connected to the network simultaneously. And those thousands of devices, they will cause massive, huge traffic to your network. And the current systems are not designed to serve these many devices. So you need to come up with a new design, new technologies, new modulation schemes that can serve this huge demand, huge traffic. How can you build an Internet of Things device? So you come to the chair, for example, you want to know this chair, and infinity amount of application. You want to know this chair is occupied or empty. So you just bring a chip, a wireless chip, that you can program it, microcontroller, and with wireless chip, and program it with sensor. So it detects that someone is sitting or not, and immediately send a message or send an information. Now this is not so critical, to design this. With my third year students, we were able to design many applications like this, hardware and working and sellable. The thing about it is, once you collect this information is very valuable. You collect it from all the environment, all the devices. You can use it for analysis, for concluding results, for making decisions, for that's the value of this. That's something hardware, like dummy network. But then what the implication of that results from the amount of information you are collecting. This is the asset. And what can you do with it is unbelievable. It's up to your imagination. So we have Wi-Fi, 5G. These networks are going to be used for designing smart home application, smart spaces in general, smart industry, smart application, smart agriculture, smart houses, smart building, smart cars. Exactly what smart means actually. These are catchy names, commercial names. Smart means give that object the wireless connectivity and the cognition to be able to sense, send, take action. Sensing, actuating, and communicating. These are the three senses that we human beings are in need of them for any activity we do. And you are enabling the dummy objects, the dummy physical things to do this. Then you somehow convert it to living entities on your environment or in your building or whatever. You just imagine with me, you need to think of the implication of that and what's going to happen if these things are becoming a reality. So even body area networks, communication going through your body, inside your body, around your body, this is always also possible. For example, I saw some research groups designing antennas inside their bodies and communicating and sending information. And many more applications as well, which are going to really shape the future, the one we are living in. So it's very nice to have these applications, very interesting ones. We like them. They make our life easy. It enables us to be more productive, more innovation, more production, more prosperity to our society. But is that coming for free? Everything comes at a cost. And this brings new challenges, new problems, new issues you need to address and solve. And this gives opportunity for you, the engineers, the researchers, to work on these challenges, because a job, means you have a problem and you need to solve it. If you don't have a problem, then you don't have a space to work with us or for us. You understand me? So you must be happy when there is a challenge, when there is a problem. Don't be afraid. This opens doors for you to prosper, to innovate, to bring your intelligence to the table, and to bring new ideas and solve the critical problems that the world is facing and struggling with. Exactly. So you have network and radio challenges. how to achieve gigabit per second data rate with no errors. This means with extremely high reliability and low bit error rate performance. How to achieve that with efficient energy communication system, with low latency, with reliability and ubiquitous coverage. And this has to be done while you are limited with some resources in terms of spectrum. Spectrum is the available resources you can transmit your information over it, with limited computational power, with limited energy, with limited latency. So within this framework, what can you do? So this is the thing, it's not without any constraints. So we have not only network and radio challenges, but also device challenges at the mobile handset. The complexity, the size, the power, the cost, the frequencies, how do you, for example, we have Wi-Fi, we have radio frequency, we have GSM, 3G, LTE. How to design all these systems, the receiver of all these systems inside your phone, one single phone, so that you make your phone capable of communicating or working on any technology. How can they coexist with each other in an efficient manner? You need to think of that. You need to be able to handle that and find practical solutions for that. Plus multiple antennas, multiple radio integration and coexistence between them. See, this is a mobile phone, for example. What it has CPU, memory, Wi-Fi chip, millimeter wave chip, cognitive radio chip, GPS chip, radio wave and FM chip, and many other chips. For each technology you need a chip. This seems to be inefficient. How are going to coexist with each other in a limited size? You know, in the old days, we used to like small phones. Yes, small size phones. In the old days, because at the beginning they were very big, very bulky, and we used to hate them. So the competition, if you remember Nokia phones, was to acquire small phones. The smaller it is, the better it is. But then after that, the game has changed. The bigger the phone is, the better. Why? Because the application has changed. Now you need bigger screen, you need to see things clearly, higher resolution for touch screen, taking images, this and that. So I believe history might reverse itself back again. You might now, with the current technologies and the future available capabilities, you might now you don't need a phone, you just maybe a ring in your finger, and this opens a screen on the air in front of you, and touch it with your fingers. Your finger become the mouse, and your screen become on the air. You don't need and your CPU and RAM and everything, you have 6G capabilities, very high speed communication system, low latency. You don't need to have them on your phone. They are on the cloud. They instantly come to you. Yes? Don't you hear of system like infrastructure as a service, software as a service, infrastructure as a service, VPS, virtual private server, and those are on the cloud. You don't need computing resources anymore in your PC. For example, until recently, we were the laptop that has more memory or more hard disk size, the price of it is more. But in the future, you won't need this. In the future, because all the computing, the power of your computer can be on the cloud. Why it's possible? Because you have very fast internet, where you have gigabit communication. With a glimpse of an eye, goes forth and back, as if it's a desktop in your hand, because of the speed of the internet. So life, industry, everything is going to change. The ones who are building their business based on selling laptops might go bankrupt if they don't cope up with the technology. They must change. They must adopt new technologies. Because in the future, really, this is what my expectation, my prediction, my prophecy, that we are going to start liking small phones. Even, why should I carry phone that, oh, I forgot it, it's not fitting in my pocket, I have to keep carrying it, it's bothering me, it's not convenient, and the battery finishes, this and that. Why don't you have something extremely simple and light, and you can put it like necklace, bristle, or whatever. Yeah, exactly, like, and it becomes like the mouse is your finger, the screen is the wall, or anything you make use of it on the street, or while you are sitting here, you might use this as a screen. And you touch it and you do, and the resources, including memory and CPU, they are in the cloud, and you have 5G capabilities, things coming forth and back very quickly. You don't have this. You don't need this. So future is very, very unpredictable. You can never predict it. So you must imagine things and prepare yourself for. So software-defined radio is one of the possible solutions for the coexistence of multiple technologies. So since I told you we have multiple wireless technologies, including Wi-Fi, WiGig, Li-Fi, 5G, 4G, 3G, 2G, this and that. We have too many things actually, and this becomes inefficient if you want to design a separate hardware for each single technology. So the point here, can you have one hardware or minimal number of hardware components and configure their functionality in software to do these things? So this is the basic concept of software. You don't need to do everything using hardware components and hardware devices. Some of these hardware devices can be shareable among these technologies, and the thing that manages the operation and the distribution of these resources among the technologies can be done by software. And that's why we call it software-defined radio, a radio defined by software configuration. And this is going to be somehow more efficient, because you might have one hardware setup and just with different softwares, which is more efficient. Have 10 hardware setups with 10 softwares, or one hardware setup with 10 softwares. It reduces your cost, and it makes your system more efficient, reduces your power consumption, your latency, and this makes you different than the other manufacturers, and you can sell your product more easily. So this is the thing. Yes.
Of DSP.
Digital signal processing component. This A to D, analog to digital conversion, and after that you have digital signal processing. And this DSP is actually the software, the programmable software that you can control it. So, what's the other problem that we have beside the components and the design of the receiver? Running out of spectrum. What's a spectrum? You know, each country has certain frequencies allocated to this country. It's actually the air. And this is, since it's something for the country, it's controlled by the government. Suppose you are a wireless technology company that wants to build a wireless system, and you want to serve customer, then you need to apply for a license from the government and tell them, I need these many megahertz so that I can use them to serve my customers. And this is very costly. Usually they sell them for millions of dollars. And now, the more data rate you need, the more spectrum you would require. And they made a study and they found out that in 2013 we were in deficit actually. The demand, the available resources were not coping up with the huge demand on data. And as you can see in 2014 the deficit was even more. We are not able to cope up with the demand. So where to go then? The only way to go is to acquire more spectrum, more bandwidth, so that you can send more data. But the problem when you go for higher frequencies, for example, GSM network, anybody knows what frequencies GSM network uses? 800, 900 megahertz, 1.8 giga. Wi-Fi, 2.4 giga. And 5 giga it uses. Now, the frequencies which are between 400 megahertz till 3.6 giga, we call them sometimes the golden frequencies. They are very precious frequencies, very beautiful for propagation. These frequencies can propagate through the walls, through buildings, through trees, can reach up to 50 kilometers sometimes, even more. Like FM signal, 88 megahertz, can reach to really hundreds of kilometers. Yes, you are here, you can listen to Istanbul FM base stations sometimes. I don't know if you are far enough. But where is the problem? What limits this? Why cannot you use this for wireless communication? Why cannot you use very low frequencies, which are good for propagation, for wireless communication? Mass. Yeah, exactly, mass. But beside that, you are not an FM base station. You are communicating on downlink as well as on uplink. The user needs to talk, not only receive. So if the user with this phone cannot transmit too much power. Its power is very limited, so its range is limited. So you must make sure that the base station is near me. Yes? That's why I very much like the frequencies that propagate for too long and can reach far distances. But then I cannot reach these base stations back. But for FM, I don't care because I have only a receiver for FM. Have anybody talked with FM? Nobody. I mean, you cannot talk with FM. You just receive from it. And that's why we can go up in the frequencies. Now, what's the good thing about 900 megahertz also? That when you design the antenna, the antenna can fit within your phone. But for extremely low frequency, the antenna will be a little bit large, like FM antenna. Can you listen to FM from your phone without putting your headset? No. The headset acts as an antenna, and still the quality is not that good. In a car, you need to have really long antenna a little bit. So usually the antenna is quarter the wavelength. The higher the frequency, the lower the wavelength. So you can fit within your mobile phone. So these are the two constraints. Power, I need to communicate back with the base station, and antenna, I need the antenna to fit within this. Yes. This is the thing. But anyway, I'm limited. In any way, I'm limited. These are very critical information. You can take notes of them so that you can remember them, because they help you in the design process of communication system in the future. You become a critical thinker as an engineer. Why this? Why that? Why it's not like, why don't we go for high frequencies? Since we are limited, the problem with low frequencies, you cannot get too much bandwidth. They have very favorable propagation conditions, but you cannot get too much bandwidth. And I need too much bandwidth so that I can serve users with high data rates. I need video streaming. You cannot serve video streaming on a GSM network operating on 900 megahertz, because the amount of bandwidth, do you know that companies are operating and serving millions of users using 3 to 4 megahertz sometimes. 3 to 4 megahertz. I mean, a very high quality video stream can take this. But since you are using voice communication, doesn't require too much data. That's why it's okay for voice, but for data not. That's why now the technology is pushing for higher frequencies. But again, higher frequencies, although it can provide me with higher bandwidth and can give me higher data rates, but the problem with it, it cannot propagate for long. It can, some of the high frequencies like 60 gigahertz and millimeter wave cannot even penetrate the wall. And this limits my communication range. So it's a trade-off process. You gain in something, you lose in other things. How to optimize, how to minimize your losses, maximize your gains. This is your job as a communication engineer, as a wireless engineer. So that's the critical point that you need to. So the Internet of Things as well is coming. Not only the applications are increasing, you are requiring hungry data application like video streaming and mobile application. Anything you do on your phone now, anything you do in your phone, you need an internet for it. Internet has become like the gas, the petrol of your car. This is your car. Assume it like this. Your car without petrol, without fuel, can it work? It cannot work. It's useless. Although it's very expensive hardware, very expensive physical object, but without something that makes it move, and the same, the internet is like the diesel of your phone. Without internet, you cannot make use of any of your application. It's useless. So that's why exactly the hardware is not a matter of hardware. The great competition now. Give you an example that can justify why the hardware is not the most critical thing. The most critical thing, how to provide the internet. Nokia, after the competition between Nokia and the other companies, as everybody knows, Nokia phones now, they are abundant. Nobody's using them. They are not available in the market. They lost. They couldn't compete because of the new smartphones and this and that. But they know, deep in their heart, that the hardware, although they lost and this and that, but they are very critical thinker. I mean, now they are focusing on building the networks that provide the internet, that provide the diesel, the petrol, the fuel for your phones. Because at the end, this hardware can be given for free. But what would you do with that hardware if you don't have internet? So the competition must not be here. The competition must. The only thing that's sellable for these phones now. What are the great new features in the additional available phones in the market? Mostly the camera. Yeah, they are making use of the phone as a camera. They are not. But if you come at the communication side, the important thing is no longer the hardware. The important thing is the internet itself. So it's something trade-off. You need to look at many different parameters and optimize your solution accordingly. So in general, if someone asks us, what's the Internet of Things? Exactly, Internet of Things is the ability to make any object able to sense, communicate, and act. It can be sensor. Sensor doesn't act or actuate, it just sense and send. It can be an actuator where it just communicates, receives and act, like a robot arm or something you remotely control it. It can be both. But it's something, give the object the capabilities that the human being has in terms of seeing, acting, and communicating, expressing. So this includes most of the devices inside your home, from the refrigerator, the TV, most of the appliances in general. And the value of the Internet of Things, as I just mentioned, not only in making things smart, but in the data that you gather, and in the great application you can produce out of this. So these are the different areas where you can apply your Internet of Things. Consumers at home, smart infrastructure, security, surveillance, healthcare, transportation, industry, retail. Now you are studying, you are studying wireless communication, and the good news that you can talk with anybody in any industry, in any field, and find something common between you and him. You tell him, what are you working on? What are you doing? I'm doing this and this and that. Tell him, I can make this more efficient, more smart, more by doing this thing for you. Wireless opens you to infinity number of fields. With everybody can talk. With everybody you can integrate and make Internet of Things application for his company so that you can make things smarter. So that's very nice thing actually. We have become like computer engineers where they can make software for anything. Also now you can make things communicate and talk and actuate and sense in any domain. Whether agriculture, you might see agriculture is completely far domain from your expertise. But still you can make it smart, intelligent. Industry, you might go to a factory and see that you have no relationship with it. They don't employ you, they don't need you, If you make it smarter and more, then they need you. So this is what's going on. So we can stop here for now, take short break, and then resume after 5 minutes or 10 minutes. Thank you.